Hello, welcome to Astronautics for Exploit. Hi, I'm Dr. Ayanshola Ogundele. I'll be presenting Suborbital Space Tourism Trajectory. The overview of my presentation is as follows. Blue Origin Trajectory, Galactic Trajectory, UP Aerospace Trajectory, XCOR Aerospace Trajectory, Copenhagen Suborbitals Trajectory, CALT Trajectory, and EADS Astrium TBN Trajectory. Blue Origin Trajectory. The New Shepard suborbital rocket utilizes a two-part design consisting of a 6-person crew capsule, which sits atop a 60-foot tall reusable rocket. The vehicle is built to launch vertically at speeds reaching Mach 3, then separate at a height of approximately 100 kilometers, at which point the rocket stage will guide itself back to Earth, while the capsule makes a more leisurely return route under the gentle drag of 3 parachutes. This picture shows New Shepard containing crew capsule and reusable suborbital rocket. The New Shepard suborbital spacecraft is made of a capsule and a booster rocket that launches vertically from a pad. The capsule is designed to serve as a research facility and to accommodate 6 humans on board. This picture shows New Shepard and crew capsule flight trajectory. Blue Origin is aiming to use the crew capsule for studying microgravity physics, gravitational biology, technology demonstrations, and educational programs. This picture shows New Shepard crew capsule, which is aimed to achieve these objectives. In this picture, we have the New Shepard flight experience. Starting from rocket liftoff, at Mach 3 plus, rocket accelerates to space as astronauts feel 3 plus Gs, and this occurs at T plus 2 minutes. Then 0G begins. Capsule separates from booster and astronauts unbuckle as weightlessness begins. This is at T plus 3 minutes. Then the capsule moves above the Kármán line, which is 100 kilometers mean sea level. Apogee. Weightlessness continues at T plus 4 minutes. Astronauts rebuckling. RSS first step descends and re-enters the atmosphere. The sensation of gravity begins to return, and this occurs at T plus 6 minutes. Parachute RSS first step drifts back to Earth under parachute at 26 kilometers per hour, and this occurs at T plus 9 minutes. The gentle landing. The capsule lands softly at 1.6 kilometers per hour in the West Texas desert, and this occurs at T plus 10 minutes. The booster re-entry. Booster lands autonomously on the landing pad 3.2 kilometers north of the launch pad, and this occurs at T plus 4 minutes. Booster lands at T plus 7 minutes, while the capsule lands at T plus 10 minutes. 9th New Shepard suborbital flight trajectory. At 0 countdown, there was ignition of the engine at the base of the 60-foot tall rocket. 8 seconds later, booster and capsule leaped off the pad into the air, and there was continuous acceleration so as to gain altitude. At 2 minutes 20 seconds into the flight, after the rocket had achieved the maximum ascent velocity of about 2,236 miles per hour, the main engine cuts off, and the capsule is separated and then glides into space. This picture shows New Shepard Mission 9 liftoff. 20 seconds later, there was firing of the Aerojet Rocketdyne built solid rocket motor at the base of the capsule. drogue chute deployment at about 8,000 feet. While the vehicle was falling at some 200 miles per hour, 3 drogue chutes, drag parachutes, are deployed. Flight profile for New Shepard Mission 9 is shown in this picture, where we have the New Shepard liftoff, separation, capsule escape motor vias, then capsule free flight, then capsule landing, then drag brakes deploy engine relights, and boosted landing. Landing at an altitude of about 7,000 feet. After the booster had slowed to some 375 miles per hour, the BA-3 engine ignited for a second time in order to perform a landing burn, touching down softly on a pad about 2 miles north of its launch pad. These pictures show landing of New Shepard booster rocket and crew capsule firing its retro thrusters during landing. Virgin Galactic Trajectory. Virgin Galactic mission is to become the space line for Earth and to open space to everybody. Here launching space vehicles are White Knight 2 and Spaceship 2. White Knight 2 is a custom-built 4-engine dual-fuselage jet aircraft designed to carry Spaceship 2 up to an altitude of approximately 50,000 feet. Spaceship 2 is a reusable winged spacecraft designed to carry 8 people, including 2 pilots, into space safely and with high frequency. This picture shows a huge carrier plane, White Knight 2, lifted Unity 50 miles above Earth's surface. This picture shows different stages of flight of Virgin Galactic. Stage 1 is pre-flight. Here, the person that intends to fly will be welcomed, and the loved ones also welcome to Spaceport America 4 days prior to the space flight. And this is where all the training will be provided and preparation required to secure every second of the space flight. Then stage 2 is the climb stage. The mothership aircraft will carry the spaceship and its crew to launch altitude where the air is thin and to the cusp of a life-changing experience. Stage 3 is the boost phase. Seconds after the spaceship's release from its carrier aircraft, the hybrid rocket motor behind the cabin will fire up, and around 6 seconds later, then the person will pass through the sound barrier, that is the astronauts. Outside the large windows, the sky will change from blue to purple and finally to black as the astronauts leave the Earth's atmosphere. Stage 4 is the space. As the rocket motor shuts down, the cabin is transformed from 3.5G rocket ship into a unique, spacious zone for exploration of weightlessness and a silent viewing platform for the greatest show of Earth. Stage 5 is the re-entry phase. With the thickening atmosphere outside the descending spaceship comes the return of gravitational forces. The rotated or feathered tail booms act as powerful air brakes, slowing and stabilizing the spaceship in readiness for the final glide to a runway landing at Spaceport America. Stage 6 is the astronauts phase. Then the early astronauts are pioneers of the new space age, helping transform access to space for everyone. This picture shows Virgin Galactic flight sequence, which is as follows. Takeoff. The mothership White Knight 2 takes off with Spaceship 2 mated under its wing. The release. The mothership releases Spaceship 2, and Spaceship 2 ignites its rocket motor. Then the boost stage. Spaceship 2 climbs vertically. The apogee stage. Spaceship 2 reaches space, and pilots experience microgravity. The re-entry phase. The journey home begins as Spaceship Two re-enters the Earth's atmosphere. The glide phase. The booms, tower, and Spaceship Two glides to the runway. And the final stage is the landing. Spaceship Two glides to a landing. Virgin Galactic is now using a rocket to launch tourists to space. Spaceship Two Unity spaceplane will head towards space strapped to its mothership, which is referred to as White Knight 2. Unlike most space flights, VSS Unity, which is the Spaceship 2, is carried to the edge of space by the White Knight 2. This picture shows Spaceship 2 flight path. White Knight 2 and Spaceship 2 flight path and trajectories. At around 50 miles above the Earth's surface, which is the border of outer space as defined by NASA, Unity will detach from its mothership. Within seconds, the spaceplane will engage its rocket motor, and Unity will fly at a near vertical angle into suborbital space, eating 3.5 times the speed of sound. This picture shows Virgin Galactic Spaceship 2 at the edge of space, about 80 kilometers above the Earth's surface. After the rocket motor has fired for around a minute, the pilots will safely shut it down, giving riders around 4 minutes of weightlessness. The pilots will then swivel Unity around and return it to Earth, landing it using a splayed tail system like a shuttlecock to control its re-entry. This picture shows White Knight 2. Unity will then glide back to the ground, landing on a runway, just like a commercial plane. This picture shows Spaceship 2. White Knight 2 and Spaceship 2 scenario videos are shown here. The gliding, the drop-off of the Spaceship 2 by the White Knight 2. This picture shows White Knight 2 and Spaceship 2 flight path, where we have the booms being lower and Spaceship 2 glides home. Spaceship 2 and White Knight 2 separate. Rocket motor ignites and the vertical ascent commences. Then Spaceship 2 reaches maximum altitude and passengers experience microgravity. Spaceship 2's booms move into the further position, ready for re-entry. Then the journey home begins as Spaceship 2 re-enters the Earth's atmosphere, and the booms lower and Spaceship 2 glides home. UP Aerospace Trajectory. The Space Loft is a reusable launch vehicle that was developed by UP Aerospace in 2006 as a microgravity research platform for education, scientific research, and commercial payloads. The vehicle consists of an expendable carbon composite solid rocket booster, avionics and recovery section, and a payload bay. This picture shows Space Loft 14 launch of November 22nd, 2019 at about 8:19 a.m. from Spaceport America, New Mexico. The heart of the Space Loft system is the payload transportation system. Space Loft is ground launched from Spaceport America using a remote hydraulic launcher and automated launch systems. The solid rocket motor burns for 12 seconds and reaches space within 60 seconds. Then a spin system slows the roll rate to near zero, where microgravity experiments can begin to be conducted. The payload section remains weightless in excess of 4 minutes, during which time the experimental technologies are exposed to the space environments where they are expected to operate. This gives researchers critical feedback about their technology, which aids in the maturation of technology for future space missions. During the re-entry phase of the flight, the booster section is released, and the payload and recovery sections are balanced to trim in a horizontal orientation so as to slow the vehicle. In this picture, we have the space loft trajectory. The launch and boost phase occurs at 12-second burn. Then we have the ascent coast. The spin occurs at T plus 50 seconds. The payload experimentation starts at microgravity space environment. Then 115 kilometers apogee at 150 seconds. 4 minutes microgravity time, followed by booster separation, then re-entry into Earth's atmosphere. This followed by flat spin descent, then the drogue chute deployed, and followed by the main chute deployment at drogue plus 10 seconds. Then finally, we have the touchdown at 30 minutes. XCOR Aerospace Trajectory. XCOR was a proposed suborbital horizontal takeoff, horizontal landing rocket-powered spaceplane that was designed by the XCOR Aerospace in order to compete in the emerging suborbital spaceflight market. The lens was intended to carry one pilot, a ticketed passenger, and/or a payload above 100 kilometers altitude. This picture shows the XCOR lane. In 2016, XCOR altered the development of the XCOR lane but concentrated on the development of liquid hydrogen rocket under contract with United Launch Alliance. XCOR Aerospace became bankrupt in 2017 and its assets sold to build a plane company which focuses on education instead of suborbital flight. In this picture, we have XCOR Lane Mark II single-stage suborbital spaceflight, which starts with horizontal takeoff from runway, powered ascent with maximum airspeed of Mach 2.9, plus 3 minutes engines off, and this occurs at 58 kilometers. Then we have the coast upwards at plus 4.6 minutes. We have the apogee, which is 103 kilometers, and this is the microgravity environment. This is followed by re-entry. Then we have the max G-force at pullout, which occurs at 4G, followed by glide and circle. Then finally, horizontal landing. The total time is estimated to be between 25 and 30 minutes. Pre-launch protocol. Lane Mark II is equipped with its own fully reusable rocket propulsion system to depart a runway and return safely, breaking the sound barrier faster than a bullet. At the takeoff phase of the space flight, tourists will feel acceleration from the 4 powerful 5K18 rocket engines. This picture shows XCOR spacecraft. Engine cutoff. The height, as only 500 people have ever seen it, will be seen when the engine cut off. At an altitude of nearly 60 kilometers, the pilot will cut off the engines. 4 running rocket engines, one moment, perfect silence the next. Then, as stated by Isaac Newton, the parabolic flight will begin. This is the XCOR Mark II picture. Re-entry, that is gliding on. After about 5 to 6 minutes in space, the Lane Mark II will begin its silent descent back to Earth. A pull-out maneuver will be used to reduce the speed tourists will experience, forces up to 4G for 10 to 20 seconds. Then they will glide for approximately 25 minutes while enjoying the feel and land on the runway at Mojev Spaceport. XCOR Lane spaceflight trajectory is shown in this picture. Copenhagen Suborbitals Trajectory. Booster rocket. The hybrid exo-atmospheric transporter, or EADS, stands about 9 meters high and is a real-scale rocket with a 640 millimeters diameter tube and uses liquid oxygen for fuel. Operation. The heat booster would burn for about 60 seconds, providing 40 kilonewton of thrust, and this results in less than 3G, making the trip feasible for humans to endure in an upright position. This picture shows the flight trajectory for the 8th rocket, where we have launch using tower, boosted jettism, zero-G parabola, atmospheric re-entry, drogue parachute, then followed by main parachute deployment, then touchdown. The Tycho Brahe capsule will provide a single passenger capsule with a full fill through a polymer plexiglass dome so that the person can see and experience the entire ballistic ride. It has a pressurized volume, providing support for one upright standing and or half-sitting person. It will also have additional pressurized space around and behind the astronaut, and this is available for several other systems necessary for the flight procedure and to support additional scientific and commercial projects. This picture shows Tycho Brahe capsule and petit medicine inside the Tycho Brahe capsule. China Academy of Launch Vehicle Technology Trajectory. CALT designed two versions of spaceplane vehicle that would take off vertically like a rocket and land on the runway automatically without any ground or onboard intervention. It will burn liquid methane and liquid oxygen. Rocket plane version 1 has a mass of 10 tons and a wingspan of 6 meters, capable of flying 5 people to an altitude of 100 kilometers, where space officially begins, at speeds up to Mach 6, giving 2 minutes of weightlessness. Rocket plane version 2 is a scaled-up 100-ton version with a 12 meters wingspan, which could fly 20 people to 130 kilometers at Mach 8, giving 4 minutes of weightlessness. This picture shows Chinese winged rocket designed to be able to carry 20 passengers. EADS Astrium TBN Trajectory. Airbus Defense and Spaceplane Flight Path. After takeoff, the plane reaches an altitude of 12 kilometers. This classical aeronautical phase can last for 45 minutes. The pilots will then shut down the jets and start the maiden engine rocket engine at the rear of the vehicle. The plane then races along a vertical trajectory. For 90 seconds of flight with a top speed of Mach 3, the plane is rocketed upwards, and the maximum acceleration is 3G. This picture shows Astrium Suborbital Space Plane. At an altitude of 60 kilometers, the rocket engine is shut down and the plane continues to climb up to a maximum altitude of 100 kilometers. This is the weightlessness phase. Then the plane gets down to 15 kilometers at the angle of attack, being progressively decelerated by the atmosphere. At this altitude, after transition to aeronautical mode, the jets are reignited to bring the plane back to a classical landing strip. This picture shows Astrium Suborbital Space Plane, where we have the aircraft climbing, then rocket engine ignition cut off, the acceleration at 3G, rocket engine cut off, then the accumulation above 100 kilometers, aero braking in the atmosphere with maximum deceleration of 4.5G, then transition from space to aeronautic mode, and finally aircraft landing. For more information, contact Astronautics for Exploit. Thank you.